So good morning, all of you. How are you all? So this is Rav Shankar sir, chemistry. Welcome back to RS Academy. In last session, we have discussed so many points regarding to basics of class 10 chemistry. At the same time, I have done one video regarding to chapter number 1, chemical reactions and equations. So please go through that. So after that one, so let me ask one question in this session. How do we come to know that? How do we come to know that? How do we come to know that? Come to know that a chemical reaction a chemical reaction has taken place. So in last session I have done what is but by chemical reaction, the reactants and products in detail. So please go through that video. So after that let us move on to next one, that is how do we come to know that a chemical reaction has taken place, whether chemical reaction occurs or not. How do we come to know that a chemical reaction has taken place? So the answer is with the help of characteristics of chemical reaction. Answer is the help of characteristics of chemical reaction. Characteristics of characteristics of characteristics of chemical reactions. Chemical reaction. This is the answer for given question. How do we come to know that a chemical reaction has taken place? With the help of characteristics of chemical reactions. What are the characteristics of chemical reaction? So during the conversion of reactant into products, some chemical reactions are characterized by evolution of gas, formation of precipitate. So change in color, change in temperature. These are the called characteristics of chemical reaction. That means, so during the conversion of reactants into product, the reactions are accompanied by some observable features. So you must have seen that during the chemical reaction, so there is some observable features. These features are called characteristics of chemical reactions, like evolution of gas, change in color, formation of precipitate, change in state, change in temperature as well. So these are the characteristics of chemical reactions. So how do we come to know that a chemical reaction has taken place? With the help of characteristics of chemical reactions. What are the characteristics of chemical reactions? So during the conversion of reactants into product, some chemical reactions are accompanied by some observable features. So these features are called characteristics of chemical reactions. Now let us talk about characteristics of chemical reactions one by one. So let me write first of all how many characteristics of chemical reactions are there. Write down characteristics of chemical reaction. First one is evolution of gas. Evolution of evolution of gas. Some chemical reactions are characterized by evolution of gas. Second one is change in color. Change in color. Third one is change in change in temperature. Change in temperature. So next fourth one is change in state. Change in state. Next one is change in next one is formation of precipitate. Formation of formation of precipitate. So these are the very important characteristics of chemical reactions. So evolution of gas, change in color, change in temperature, change in state, and formation of precipitate. So during the chemical reactions and during the conversion of reactants into products, some chemical reactions are accompanied by either evolution of gas or formation of precipitate, change in color, change in temperature. So with the help of these characteristics of chemical reaction, we came to know that chemical reaction has taken place. Now let us discuss one by one. Please make a beautiful note of yourself what I am writing on the board. Evolution of gas. Some chemical reactions are characterized by evolution of gas. Example. Take one conical flask. Take one conical flask which consists of few ml of sulfuric acid. Sulfuric acid formula H2SO4. Sulfuric acid also called oil of vitriol, and sulfuric acid can be considered as king of chemicals. So sulfuric acid, aqueous solution of sulfuric acid. Right. Now add few zinc granules to it. Few zinc granules. Few zinc granules to it. Zinc symbol Zn. Zinc granules. Zinc granules. Make a note of it. Zinc granules. Granules. Zinc granules. So you must have seen that the evolution of hydrogen gas taking place. Evolution of hydrogen gas taking place. H2 gas. So the reaction between zinc and sulfuric acid is characterized by change in characterized by evolution of gas. Characterized by evolution of gas. Let us write equation for this one. So how to write equation, how to balance equation, you will get in case of chemical equations topic. No need to worry about that. But I would like to write balanced equation for you. But we are discussing only characteristics of chemical reactions. So please keep that point in our mind. Right. So zinc react with sulfuric acid. You will get zinc sulfate, zinc sulfate along with hydrogen gas, zinc sulfate along with hydrogen gas. So the reaction between zinc with sulfuric acid is characterized by evolution of gas. Not only that, during this reaction, you must have seen that large amount of heat energy is generated. Heat energy is generated. It is an exothermic reaction. Please make a note of it. It is an exothermic reaction. Exothermic reaction. So this is the example one regarding to evolution of gas. Some chemical reactions are characterized by evolution of gas. Example, so zinc granules when dropped in sulfuric acid, so zinc react with sulfuric acid gives zinc sulfate along with hydrogen gas. So this is a this is the example for evolution of gas. So how will you test the nature of hydrogen gas? If you brought burning candle near to the mouth of hydrogen gas, it bond with pop sound. So this is the characteristics of hydrogen gas. So based on this, we came to know that some chemical reactions are characterized by evolution of gas. So let us take one more example to understand this in detail. Make a note of it. Next one. Next one. Take one small test tube as shown in the figure, which consists of few ml of aqueous solution of hydrochloric acid. Hydrochloric acid. Hydrochloric acid also called muriatic acid. Please keep that point in mind. So hydrochloric acid also called muriatic acid. Muriatic acid. Muriatic acid. Hydrochloric acid also called muriatic acid. Okay. Take few ml of aqueous solution of hydrochloric acid in a test tube as shown in the figure, and add few grams of baking soda. Baking soda formula NaHCO3. Sodium hydrogen carbonate, also called sodium bicarbonate, and commonly called as baking soda. So what will be happen? You must have seen that evolution of carbon dioxide gas. evolution of carbon dioxide gas. The reaction between baking soda and hydrochloric acid is characterized by evolution of gas. So let me write equation. Look at the board, all of you. So sodium bicarbonate baking soda react with hydrochloric acid, that is HCl, gives sodium chloride NaCl plus H2O plus, let me rub this one, plus carbon dioxide gas. H2O plus carbon dioxide gas. Carbon dioxide gas. This is a characteristics of, that means is a, this chemical reaction is characterized by evolution of gas. Here you must have seen the evolution of carbon dioxide taking place. Listen to me, how will you test the nature of carbon dioxide? We have three tests. One is carbon dioxide. If you brought burning candle, it carbon dioxide extinguishes the burning candle. Fire extinguisher. It extinguishes the burning candle. So the test number one. Second test, it turns lime water milky. When carbon dioxide gas passes to the lime water, so colorless lime water turns into milky white. So let me write that equation. Carbon dioxide when passed to the lime water for a calcium hydroxide solution, it's a colorless and becomes milky white color. So formation of white precipitate. This is for milky white precipitate. Milky white precipitate. So we can test the nature of carbon dioxide with the help of two tests. One is carbon dioxide extinguish the burning candle. If you bring burning candle near to the carbon dioxide, so it will extinguish the burning candle. Next one is carbon dioxide can be identified by passing carbon dioxide through the lime water. So clear lime water becomes milky white. So these are the two confirmation tests for carbon dioxide. So this reaction also characterized by evolution of gas. Is it clear to you? So in case of types of reactions, I will give number of equations and number of reactions regarded this kind of regarded chemical reactions. No need to worry. So I would like to give at least two examples for each characteristics of chemical reaction. So we have done, that is evolution of gas. Some chemical reactions are characterized by evolution of gas, right? So now let us move on to next type, that is change in color. Change in color. Change in color. Am I clear to you? Right. Change in color. So next characteristics of chemical reaction is change in color. Change in color. Change in color. Some chemical reactions are characterized by change in color. Example, take few ml of aqua solution of potassium permanganate. Formula KMnO4, potassium permanganate, which is a purple color liquid, purple colored substance. Take few ml of aqua solution of potassium permanganate. So what is meant by aqua solution? If anything dissolved in water, it must be considered as aqua solution. For example, if you dissolve potassium permanganate in water, it will be considered as aqua solution of potassium permanganate. If you dissolve sugar in the water, it will be considered as aqua solution of sugar, right? So we need to take aqua solution of potassium permanganate. The aqua solution of potassium permanganate purple in color, right? Now add few drops of lemon juice. Right. So observation is, when add few drops of lemon juice to the purple colored potassium permanganate, it becomes colorless. This is observation. Purple color becomes colorless. Purple color becomes colorless. So just change in color. So here purple color liquid turns into colorless. Right, let me write equation. So listen to me. When few drops of potassium permanganate, so few drops of lemon juice added to potassium permanganate. So lemon consists of citric acid. Citric acid formula C6H8O7. Citric acid. Please make a note of it. Citric acid. Citric acid. C6H8 C6H8O7. Citric acid. So it's react with citric acid C6H8O7 and gives HMnO4 permanganic acid and potassium citrate C6H5K3O7. This one is permanganic acid, permanganic, permanganic acid. This one is potassium citrate, potassium citrate, potassium citrate, potassium citrate. This one is citric acid, citric acid. This one is potassium permanganate, potassium permanganate. So this reaction is example of change in color. Some chemical reactions are characterized by change in color. Example, the reaction between citric acid and potassium permanganate. In the examination, you will get question like this: name the acid which is decolorized the potassium permanganate. Citric acid. Name the acid which is decolorized the potassium permanganate, that is citric acid. According to our syllabus, citric acid. Okay. So this one is a example for change in color. Next, one more example I would like to give. Make a note of it. Next one. Next one. Take few ml of aqueous solution of potassium dichromate. Potassium dichromate formula K2Cr2O7. Potassium dichromate. The color is orange color. Orange color. Orange color. Potassium dichromate solution is orange color. Orange color. When sulfur dioxide passed through the orange colored potassium dichromate, orange color potassium dichromate, when when sulfur dioxide gas is passed through the orange color potassium dichromate, orange color potassium dichromate, it becomes green color, becomes green. So orange color potassium dichromate changes to green. So this is the observation. When sulfur dioxide gas passed through the orange color potassium dichromate, so orange color solution turns into green color. So this is an example of change in color. Let me write equation. So these equations are very important. Please copy each and every point. So potassium dichromate formula K2Cr2O7. Here we need to add few drops of sulfuric acid. So sulfuric acid. So this is called acidified potassium dichromate. So we need to add few one or two drops of sulfuric acid to potassium potassium dichromate during the reaction. Potassium dichromate react with sulfur dioxide, also consists of sulfuric acid, gives potassium sulfate plus, let me write down, potassium sulfate plus chromium sulfate, chromium sulfate plus water, chromium sulfate plus water, chromium sulfate plus water. So this is a green substance, this is a green substance. The solution turns into green color due to formation of chromium 3 sulfate. Is a green color substance. So that's why the orange color potassium dichromate changes to green color. So these two examples are very, very important. These two reactions are characterized by change in color. Right. Next one, change in temperature. Third one, change in temperature. Change in temperature.